Welcome to EDU World Space.
In this question, we have a projectile that's being launched from the ground, okay, at an angle theta from the horizontal, and then at the maximum height, okay, it splits into two fragments, okay, 1 and 2, okay, and then both fragments travel with a speed that's relative to the initial projectile, okay, but equal and opposite direction, okay, while at the top, okay, the velocity of the projectile is Vp to the right. Okay, so this one, just make a note, is relative to the projectile just before explosion. Okay, so during this process, when the projectile is moving up from the ground to the maximum height, okay, it travels a horizontal distance d. Okay, so we are given that fragment 2 went back to point A. This is A. And then fragment 1 will also continue to move forward to the right. It will land eventually. You want to find the distance between the fragment 1 to point A, okay, when fragment 1 lands. Okay, so this problem is about relative motion. Okay, so we first write down the relative motion equation. Okay, so velocity of fragment in the Earth's frame, okay, is equal to the velocity of fragment in the projectile's frame plus the velocity of projectile in the Earth's frame. Okay, so this is the relative motion equation. So and then we take right to be positive. Okay, so over here we'll just work along the horizontal direction because the both fragments 1 and 2 will take the same time to land because at the maximum height there is no vertical components of the velocity, so they will take the same time to reach the ground. Okay, and then so we want to find v1 relative to the velocity of v1 relative to e. So this is actually negative v plus vp. Okay, and the speed of no, this is fragment 2. Okay, and then the next one is fragment 1. Okay, fragment 1 is v plus vp. Okay, yeah. So fragment 2, we know that fragment 2 goes back to point A. Okay, so this means that negative v plus vp equals to negative vp. Okay, this means that v is 2 vp, and so v1 v1 in the Earth's frame is 3 vp. Okay, and since let t be the time for the projectile to reach max height. Okay, so vp t equals to d. Okay, and the horizontal distance traveled by fragment 1, okay, is equal to 3 vp t. Okay, this is 3D. Okay, so the distance between fragment 1 and point A is equal to 4D. Okay, from the diagram. Okay, if I draw the diagram again, okay, so this is the point that they separate, and then so 1 and 2, okay, we know that 2 goes back, so and for 1 it continues to travel, okay, and this is 3D, okay, and then this is D, so the distance between fragment 1 with point A is going to be 4D. Okay, so the answer is 4D, and that's all for this question.